For the introductory part to understand the probability, let us try to understand from the book of P L Meyer. Introduction to Probability by P L Meyer. In this universe, we observe lots of phenomena in the nature. Few of them are deterministic, few of them are non-deterministic. So according to P L Meyer's language, there are many examples of experiments in nature for which deterministic models are appropriate. For example, the gravitational laws describe quite precisely what happens to a falling body under certain conditions. Kepler's law gives us the behavior of the planets. In each situation, the model stipulates that the conditions under which certain phenomena take place determine the value of certain observable variables. For a large number of situations, the deterministic mathematical model described above suffices. However, there are also many phenomena which require a different mathematical model for their investigation. These are what we shall call non-deterministic or probabilistic models. Suppose that we have a piece of radioactive material which is emitting alpha particles. With the aid of a counting device, we may be able to record the number of such particles emitted during a specified time interval. It is clear that we cannot predict precisely the number of particles emitted, even if we know the exact shape, dimension, chemical composition, and mass of the object under consideration. Thus, there seems to be no reasonable deterministic model yielding the number of particles emitted, say n, as a function of various pertinent characteristics of the source material. We must consider instead a probabilistic model. For another illustration, consider the following meteorological situation. We wish to determine how much precipitation will fall as a result of a particular storm system passing through a specified locality. Instruments are available with which to record the precipitation that occurs. Meteorological observations may give us considerable information concerning the approaching storm system, barometric pressure at various points, changes in pressure, wind velocity, origin and direction of the storm, and various pertinent high altitude readings. But this information, valuable as it may be for predicting the general nature of the precipitation, simply does not make it possible to state very accurately how much precipitation will fall. Therefore, a probabilistic model describes the situation more accurately.